You can think of real numbers as the collection of all of the possible numbers that you encounter in high school. And so far, up to this point, we've really only looked at a small part of those real numbers, the rational numbers. We've looked at integers, we've looked at fractions. So the definition of a rational number is any number that can be expressed as a ratio of two integers. In other words, any fraction. So numbers like 2/3 or minus 11 over 9. An integer itself, like 5, can always be written as 5 over 1. So these are rational numbers. Now, any number that cannot be written as a ratio of two integers is irrational. So what are some examples of irrational numbers? Well, things like the square root of 2 or pi. Now, the ancient Greeks had a big problem with this. They thought that all numbers could be written as rational numbers until somebody came along and proved that a number like root 2 simply cannot be written as a ratio of two integers. Now, one of the properties of this fact is that when you look at the decimal equivalent of an irrational number like root 2, it never stops and it never repeats. So the first part of the decimal expansion of root 2 is 1.414213,562, and it will go on forever, never repeating and never stopping or terminating. Pi is another example of an irrational number, and you may read reports of millions of digits of pi being calculated by a computer, or people memorizing thousands of digits of pi. The first few digits of pi, 3.141592653, etc., again go on forever and never repeat. If a decimal expansion of a number does stop, like 0.25, that's a guarantee that it's a rational number. It can be written as a fraction, and you even just have to sort of spell it out. 0.25 is 25/100ths. 25 over 100 is a rational number. What if the decimal expansion repeats, though, doesn't terminate? Well, it turns out those can all be written as fractions as well, following this little trick. So let's say we have 0.7 repeating. Now, if a decimal repeats, you can symbolize that with a little bar over the part that repeats. So 0.7 repeating is 0.777, etc. And if there's only one digit that repeats, there's only going to be one 9 in the denominator. So 7 over 9 is 0.777, 7 repeating. You can follow this trick. Say 0.4 repeating, that's just simply 4 over 9. If you have two decimals repeating, let's say 0.37, so this would be 0.373737, etc., you need to have the decimals, the numbers that repeat in the numerator, and then you would have two 9s in the denominator. Same thing if you have three numbers, let's say 0.129, all three of those repeating. This would simply be 129 over 3 9s, 999. And if it's a slightly more complicated variation of this, usually it just involves moving the decimal place to the left or right, which means multiplying by 10 or dividing by 10 a couple of times, and you can convert it into a fraction. So the rule is, if the decimal repeats or terminates, it's a rational number, it can be written as a fraction. If it's irrational, the decimal will never terminate, never end, and never repeat.